Okay, we're on to Unit 2, transforming the quadratic function. Okay, so we did the absolute value function in Chapter 1, and now we're doing x squared function. So the same as what we did with the absolute value function. We'll do a table of values, input and output. Let's use those numbers: -2, -1, -3, -2, -1, 0, 1, 2, 3. And we're going to plug it into the function x, for the variable x there. So we're going to plug in -3 squared. So what is -3 squared? So that would be an output of 9. And we'll do the same for -2 when you plug it into this x. So this is going to be -2 squared, and that's going to be 4. Then we got the -1, plug it in. -1 squared is going to be 1. Plug in 0, it'll be 0. 1 squared is 1, 2 squared is 4, 3 squared is 9. And then we plot these points on the graph. -3, 9 is not on this graph. It just goes all the way to +6. So let's go ahead and graph -2, 4. -2 goes to 4. -1 goes to 1. 0 goes to 0. 1 goes to 1. 2 goes to 4. And we cannot graph 3 goes to 9. It kind of looks like a V, but it's not because it curves. If I was to do more points in between -3 and -2, like say -2.5, I would get some points that are like this curve. So it's not a V, it's more like a U. So this is called a parabola. Okay, so a quadratic function in the graph of a quadratic function, the shape of it is called a parabola. Okay, so the same that we did with the absolute value function, we need to find the domain. So what are all the possible inputs for a quadratic? It's actually the same as a absolute value function. You can input all real numbers. The range deals with the outputs. The lowest it goes, it's going to go on forever up. And the lowest it goes, this is the minimum, is 0. So the range is going to be y is greater than or equal to 0. And this is a new one that we're adding on to what we've already done with the other function. For which input values is the function increasing? So for what values of x is the function increasing? So we always go from left to right, and like thinking you're rolling on a roller coaster from left to right, you're going down right here. So on the left side here, all the way here is when you're going down, and you're going up starting here. Then you start going up, starting here, you're increasing here. So for values that are x greater than 0 is where you're increasing. X greater than or equal to 0 is the new concept that you need to understand about functions. Okay, let's do this parabola quadratic. Same thing, understanding transformations. We know that x squared is some kind of U, some kind of parabola. It has to be upside down because of the negative. And then this is kind of like the vertical stretch or shrink. So you're gonna go make this kind of a fraction. So you're gonna go well, it is already a fraction, but 1/2 is the same as 0.5. And then put a 1 under it. So what we're going to do, and we know it's upside down, so you're going to go down 1/2 and over, so that's down, and over 1. So over to the side 1. So when we graph this, is that it's still at the origin, and we're going to go down 1/2 and over 1. Down 1/2 over 1. So this really is a vertical shrink. Okay, so now, what is the domain? Well, the domain, we already said, the domain is going to go down forever, so it's going to be all reals. The range, now, this thing is going to go forever down. It's going to go forever down, and the highest it goes is this. So this is going to be y is what? Less than or equal to 0. And so where's the function increasing? For what input values is the function increasing? Well, isn't it going up right here? This is where you get on the roller coaster, you're going up, up. This is where you're going down. So for the input values, for x input values, less than 0. So the answer here is x is less than or equal to 0. The function is increasing. Okay, let's go on to the next one. This one is a shift to the left of the quadratic function. So left shift 2, and the a value here is 1 over 1. Everything's okay, so go over 1 over 1 over 1 over 1. So this is a quick sketch of the graph. The domain is going to be all reals. The range is the it's going to go forever up. So the lowest it goes is 0. So it's going to be y is greater than or equal to 0. And for what input values is the function increasing? There's your car. This is going down. That's not what we want. We want it where it goes up. So for input values greater than, x greater than -2, or equal to -2 is the answer. It's a quadratic shifted up 3. The a value is 1 over 1, over 1 over 1, over 1 over 1. It's a parabola. Domain, all reals. Range is going to be what? Y is greater than or equal to what? 3. And for what input values is the function increasing? Right here is going down. We want it where it's going up. So that's going to be for input values x greater than or equal to 0. Problem number 5. This one has 3 transformations. It's going to be upside down because of that. Shifted to the right 3 and down 1. This one's going to be down 1 unit, and then because of this, it's going to be shifted right 3 units. And then upside down. So right 3 units, this vertex is going to go here, and then down 1, and it's upside down with 1 over 1. Something like this. The domains are reals. So now this one, the highest is going to go is this point, and then it goes forever down, forever down. So the highest is -1. So it's going to be y is less than or equal to -1. And for what input values is the function increasing? So it's going up, and a roller coaster is going up from left to right. So this is going to be for what input values the function increasing is for y is less than. Nope, you never write down the y. It's always in terms of the x. That's why this is s. For what input values? The input values are x values. So it has to always be x. And that's going to be less than 3 or equal to 3. If this graph or this equation is shifted 2 units left, that's going to be dealing with the inside here. Left 2 units is because we're adding 2 in the inside. 3 units down, that's because we are subtracting 3 on the outside. What would be the equation of this new function? It would be y equals negative x minus 1 squared minus 2. All right, so we're done. See you next time.